Hello, this is Brett from Survivalcomms. Many have expressed interest in seeing how I convert a commercial radio microphone for service in an amateur radio, specifically the Yaesu FT2900R, which originally was equipped with the Yaesu MH48 6-pin modular condenser mic, and I will do so today for you. Much of this will transfer to a degree over to different types of microphones and radios, and the microphone we are working with today is the microphone that was shipped with the CDM series of Motorola radios. Now the part number for this microphone is Alpha Alpha Romeo Mike November 4025 Bravo, which is inexpensive and can be picked up for $5 to $15 on the surplus market. Now be advised, most of the ones that you're going to find advertised on Amazon are counterfeit new production, and those should be avoided. I recommend purchasing on eBay from a reputable reseller of surplus gear. Now let's open up our microphone by removing these 3 screws on the back of the microphone. Now this small cone here covers our electric capsule, and it can be removed to get it out of the way, and we'll replace it. Here's our push-to-talk switch. Here's where our mic lines tie in here, and you're going to see a whole bunch of components in here, but we're not going to need a lot of these components, and we're going to bypass many of them and simplify this microphone for use in this particular radio. This drawing is of a basic electret two-way radio microphone. At the bottom, we see a simple push-to-talk switch. In what we are working with today, it is a simple 2-pole momentary switch. Pin 1 of the RJ12 connector is our PTT line, and this wire will be red in color for this project. And pin 3 of our RJ12 connector is our ground line, which is black in color for this project. Depressing this switch closes our PTT line to ground, and this toggles the radio to transmit. At the center of our drawing is the electret capsule. The electret capsule has 2 pins, one of which is ground. If there is ever any ambiguity in pin identification, the pin that has continuity to the capsule body is ground. In our project today, the ground pin is grounded to the microphone printed circuit board. The second pin on our electret capsule is tied to 2 different lines from our radio. The mic line, which is pin 2 on the RJ12, and this wire is green in color. This line is connected through a 1 microfarad capacitor to the capsule, which acts as a DC block while not affecting speech. The second line is our bias voltage line. In our project today, this line is supplied with 8 volts DC on pin 4 of our RJ12, and in our project this wire is blue. We connect this line to our electret capsule through a resistor with a minimum value of 1K, and for this project I'm using an 8.2K ohm resistor. It is important that you attach the resistor on the capsule side of the 1 microfarad capacitor. The DC blocking action of the capacitor is keeping DC off of the audio line going back to the radio. There is an impedance mismatch between the 2 kilo-ohm element that the Yaesu is specified for and the Motorola microphone, if I remember correctly, is 600 ohms. The audio sounds fine to me. Well, now that we've discussed the electric condenser microphone itself, a very simple circuit, you're going to notice that we're going to end up having to repurpose one of these wires to deliver our bias voltage to our electric capsule. And we're going to use the blue wire, which is tied to the hang-up box. For those of you not familiar with the hang-up box, a hang-up box uses a grounded microphone bracket. And when the microphone bracket or the microphone's placed in the bracket, the radio operates in a selective signaling mode, meaning it will only unsquelch whenever it has a matching PL or DPL. And when you lift the microphone out of the hanger, it goes into a carrier squelch receive mode. Now, this is very important when community repeaters and things of that nature were popular, because you had multiple PL groups operating on a single RF channel, and it prevented you from trying to talk while someone else was actually using the radio. So you made sure that the channel was clear before you executed a push-to-talk sequence. And then whenever the microphone is placed back in the bracket, you only heard your traffic. So anyway, so what we're going to do next is we're going to go ahead and cut off our 8-pin modular plug here, because we no longer need that. And then we're going to use my razor knife and we're going to expose these conductors. And then we're going to go ahead and pin out our 6-pin modular connector and expose your inner conductors. And we're going to need our blue wire, we're going to need our black wire, our red wire, and our green wire. And everything else we're going to go ahead and cut away. Now that we've removed those conductors, we can go ahead and connectorize our mic cable here. And again, you need the black wire, the red wire, the green wire, and the blue wire. Now, we're going to be using the red wire is our push to talk, and our green wire is our mic lead. And let me explain why. In a Motorola microphone, the bias voltage is phantom power, meaning that there's bias voltage on this mic lead, and that is what's switched. And what happens is you have a series of transistors, and the transistors achieve the switching functionality for a push-to-talk sequence, and we do not need that in this particular microphone any longer. So what we're going to do is our push-to-talk line, which is going to be red, is going to be number 1, and number 2 is going to be our mic lead, which is going to be green. And then we need our ground, which is going to be black. And then we need our 8-volt line, which is going to be our blue one. Just like that. So we put these together, and holding them in order, we take our 6-pin connector, and we're working from the left to the right. So the far left with a hook down is going to be pin 1. So we shove this through here, and we confirm our colors. Place that all the way in there. Okay, so we have red, green, black, and blue. Now taking our crimping plier, we go ahead and apply a crimp to our connector. Examine our work, and we'll go ahead and trim away these excess length of conductors. Now strip all the components off the board except for these 2 capacitors here, your microphone element, your switch, and this connector. Now you control the field. So then, using a vibro pencil, I transect this trace, allowing use of this pad right here without it being tied to this pad for the hang-up box. We don't need that anymore. Up here at the top, go between the top contact of your push-to-talk switch and tie it to ground. Now you have complete control over the push-to-talk circuit. I then construct this capsule here, which is nothing more than a 1 microfarad electrolytic capacitor with the positive side towards my element. I have an 8.2 kilo ohm resistor tied in, and that's tied in to where it ties right into the mic element. And then this right here ties into the audio line. And I have it all assembled, and the resistor is insulated from the capacitor with this piece of silicone insulation. And all it does is drops right into the board. And this small hole here is what is going to be for our bias voltage, or blue pin. And then we solder this lead across these 2 capacitors here. And then we take this and tie this into our audio lead down here. Now you can see our microphone assembly is completed. Total build time from start to finish is less than a half an hour.
Rhinoceros, this is Platypus. I am marsupial at this time, over. I hope this helps. This is Brett from Survivalcomms. Until next time.